Good morning, everyone. We heartily welcome you to our fourth day of the FDP program. Today, we would like to introduce Dr. Sharad Sinha, Department of Computer Science and Technology, University of North Bengal, India. Dr. Sharad Sinha, MCA, PhD, is the Assistant Professor of Computer Science and Technology, University of North Bengal, India. His research area of interest includes cryptology, natural language processing. He is having 25 years teaching experience in digital electronics, microprocessor, computer architecture, communication skill, operating system, research methodology, etc. in MCA, MSc, MTech classes and PhD coursework. He completed his project in development of major Northeastern language funded by MEITY 3 years in consortium mode under the leadership of CDAC Pune. There he delivered Nepali script grammar, CLDR dictionary, corpus for the development of typing tools, keyboard deliver, spell checker, etc. He also completed his another project in Indian Language Corpora Initiative ILCI Phase 2 funded by Ministry of HRDC 3 years in consortium mode under the leadership of JNU Delhi. There he delivered Hindi Nepali parallel corpus in health and tourism domain, POS tagged and chunked for development of machine translation system. And now his ongoing project is Ishan, a system for bidirectional machine translation funded by MEITY 3 years in consortium mode under the leadership of IIT Bombay. Deliverables, parallel corpus, ML model selection, training, testing and performance evaluation. He will now discuss about natural language processing, basic tasks and the Indian perspectives. We now hand over the session to Dr. Sharad Sinha. Please, sir.
I think I'm audible.
Yes, sir, you're audible.
Yes, sir.
So good morning, everyone over here. So first of all, I would like to thank BCRAPC Academy of Professional Courses for inviting me to this program, faculty development program, and special thanks to Deepanjan Sen, who happens to be one of my students. So actually, he maintained the liaison for all this communication and all regarding the program. So as you have seen, my today's discussion topic is natural language processing, and I'll be dealing with the fundamentals and mostly in the Indian perspective because I'm working for Indian languages. I don't think that actually I'm the right person to be over here talking to you all learned persons. But I'll just be sharing my experience. I'm still learning, so I'll just be sharing my experiences, whatever I have learned. So it may be the tip of the iceberg because this field is very, very large. It has grown exponentially. So I don't think that I will be capable of satisfying all your requirements, but still I'll try my best to share whatever I've gathered through all my experiences in different projects. So first of all, I would like to declare that I'm not an expert in this field, okay? Because I had a different domain of research before, as you have heard in the introduction that particularly my PhD work was in cryptology, and I've also produced a few scholars in that area, but now I have shifted to this NLP task. So natural language processing, actually we can look back when we wrote programs handling strings like abbreviate names, sorting names, character handling, etc. So does that belong to natural language processing as it deals with the words from English language or any other language? There may be debate, but actually natural language processing as it is defined in various ways deals with understanding or and generating natural language. Natural language means the language through which we communicate with each other. Humans communicate with each other. So string handling is just mere data processing task, and that does not include the meaning, context, and other complex linguistic things. So how do we define then NLP? So natural language processing, actually, first of all, it was a field of linguistics. Now that has been incorporated in computer science, and today, actually, if you look into the definition in various sites, you will see instead of computer science, they write AI actually. But AI is being extensively used because that is the most valuable tool we have today, and also giving good results. Whatever we could not do earlier, now we can do with all the AI techniques. So actually, it began with only rule-based systems and other aspects of computer science. So I've written here computer science. So it is a field of computer science and is concerned with the interactions between computers and human natural languages. Now we generally communicate with our computer system through programming languages, high-level languages, low-level languages, and we have the systems like compilers, assemblers, and others to make those things understandable to the system. And we get back the output in the form of natural language, and actually that is written in the program itself, and how we print the lines. The machine just prints the line. It does not process the language. For example, we want to find the square root of something, then we print the square root of this. That is just embedded within the codes, and that is printed by the programming language. So the computer understands actually in the very lowest level is only zeros and ones, as we understand, and then we come higher with the low level languages like assembly language, and then we come higher up with the high level languages, programming languages, and now the human understandable language, the language with which we communicate with each other, and that is known as natural language. Now we can communicate with the system in our own language, and that is understood by the system. For example, Hey Google or Siri systems we have in our mobile phones, we just talk in our own language, and that is well understood, and again responded in our own natural language also. So I can tell my mobile to play some song on the Spotify by just telling Hey Google or Siri. and then that is responded well. So those things seem so simple, but in the background to develop those systems, you may understand that we need very complex analysis and also huge amount of resources as well. You may have noticed Google Translation 10 years back, and that was quite pathetic. Okay, but today's translation, Google Translation has become much better, although not 100% perfect. Why? Because the system is learning day by day, and it is becoming more and more accurate. So we have employed the machine learning techniques and other AI techniques to help the systems to learn, and that needs a lot of resources in the form of language and in the form of machine also. So this natural language processing makes human language intelligible to the machine. The machine can understand our language and it can respond back in our own language. So this is actually a combination of two subjects, computer science and linguistics. Linguistics, as some of you are into it also, you know that it is not only the study of grammar, but everything regarding a language, its structure, its sounds, its discourses, everything. I'll come to those points one by one later on. So natural language processing actually has two general tasks. One is natural language understanding. The machine, to make the machine able to understand what we tell the system in our own language. So we give as input some spoken and typed sentence, and the machine will work on it and will understand what it means. And another thing is natural language generation. So when it is talking back to us, responding to us in our own language, then it should generate what it wants to say in our own language. So that comprises of taking some formal representation. We may have a formal representation, we have a tabular data or something else, and from that it makes out, it constructs the sentences or sounds, because the expression may be in terms of text or speech. So it takes the formal representation. We store data in some structured manner. So from that, it works out and expresses those things in our own natural language. For example, English. I want to tell you that you can stop me anytime in between if you want to discuss anything, okay? Because it is better to interact rather than have a lot of questions at the end, so I have to come back to one of the slides. So if you want to stop me and discuss something in a particular side, then you are most welcome to do that. So sometimes our task may be a combination of language understanding and language generation. So, and a good example is that machine translation. In machine translation, the machine has to understand the meaning of the input in one language, and it has to generate the output in another language. So that is combination of natural language understanding and natural language generation. So what we will have some highlights into natural language understanding. So it may be understanding raw speech signal. So that system actually consists of speech recognition system. So and another aspect is voice recognition, but I think that does not encompass the linguistic thing. That voice recognition is mere study of various frequencies and the timbres and other parameters related to voice. So voice recognition does not have anything to do with understanding or generating the language. And speech recognition means we speak to the computer system and it understands. And that may be it may incorporate voice recognition as well. Sometimes we give a sequence of spoken words, okay? Here means spoken word means it may be typed as well, okay? Not only the sound, and that includes the syntactic analysis and that the knowledge of the grammar of that particular language. It deals with the position of the words in a particular sentence, whether it is correct or not. And yes, okay. And another thing is structure of sentence, which deals with the semantic analysis. And if you are into computer science, then you are well versed with these two terms, syntax and semantics. And actually, semantics deals with what a sentence means, and so it is actually it deals with the structure to make out the meaning. And syntactic analysis is just whether the words are properly used or not. Now, syntactic analysis uses the grammar law like subject, predicate, verb, etc. In programming languages, we follow a particular rule of that language. For example, in Python programming, we follow the Python syntax. In C programming, we follow the C syntax. And semantic actually, in the programming sense, we say it is sometimes what happens is that whether if we write a correct program using correct syntax, but still we don't get the actual result what we want. There may be logical errors. Actually, logical errors are sometimes also may be termed as semantic errors. If I say I will eat the sun, then it is syntactically correct. Everything is in proper place, but that does not make any sense, any meaning. And there are other aspects of semantics as well. Okay, so and next is sometimes we deal with the partial representation of the meaning of sentence. Sometimes we want to say something and we write other things, and also the same word may be used in different contexts. So for that we need pragmatic analysis. We'll come to this in more detail in the slides to follow. So, and finally, all these will make the final representation of the meaning of the sentence. So these are the things in natural language understanding. And natural language generation means talking back. So the computer system or any other system, digital system, wants to talk back to us in our own language. So how to do that? So it may be text or it may be speech. So first of all, we actually do text processing and then we generate the speech, because there are systems like text to speech. First, we speak. If you speak to the system, then it is converted to text. Then the text is processed, and the needful is done. Then again, we get the text, and that text is converted to speech. For example, we want to translate what I am talking in another language. So my speech has to be recorded and converted to text, and text to text translation has to be done, and then it is later converted to again speech. So for example, we have these two records in any file. So that is quite abstract, but still a little bit understandable that it is a record about a train numbered 123143, then SDAH means people living in West Bengal can actually make out the meaning. SDA, Sialdah, the code for Sialdah, and NGP. Then we have the times. And so how to say this? So the language generation phase deals with this. So here's an example that there are two trains from Sialdah to NGP. The first one is Darjeeling Mail, which you see these are all now 1, 2, 3, 4, 3, 1, 4, 3 means Darjeeling Mail. So that is actually there in the system, and it translates the data in a structured manner. This is actually not in the language. It has its own structure, but if we talk about data, this is unstructured data rather. In the linguistics and NLP deal with unstructured data. The language is not always structured, sometimes structured, but not always structured. I'm not talking about the structure of a sentence, but the data. So this is how the system may generate, but another system may generate another sentence using the same data. So it depends on how the system has been designed and or trained to generate natural language. So speech synthesis again is one of the examples of language generation. So human recordings in we can record by reading a lot of things, and then we can cut the pieces of sound and then concatenate again and reproduce different word and so on. So it's very, very complex, because you see mere robotic speaking is not actually reasonable. What we want today to produce sound as close as human beings. For example, in Bangla, we say tumi kheyecho. If I say tumi kheyecho, and if I say tumi kheyecho, so these two are different things. One is a statement that you've eaten, and another is a question, have you eaten? But the group of words are same in the two sentences, tumi kheyecho, tumi kheyecho. Only the difference is the tonality, how the pitch is varying from one word to other. So any question from some participant? Yes. Hello.
নম্বরের শীটটা দিয়েছিলাম তোকে, ট্যাগের ছয়ের যে শীটটা দিয়েছিলাম না, ওই শীটটা একটু কাউকে দিয়ে আমার
I think this is one host talking. So where was I? Yes.
Sorry, sir,
So-
for the inconvenience.
Oh, okay. So why it is complex is I gave you one example. So actually the word intonation has a lot to do in producing those variation of speech. Our Indian languages are very much having intonation in it. Okay, actually, intonation is there in every language, but in in most of the Indian languages, we have to do a lot of things with intonation, and there are stresses also. Sometimes we can express our surprise by telling the same thing. "Tumi khecho." It's not a question, but I'm surprised that you have eaten. Okay. So slowly we can grow with complicated, complex sentences. We can add one, say, ruti. Tumi ruti khecho. Tumi ruti khecho. Tumi ruti khecho. That means you have never eaten ruti, but I'm surprised that you have eaten ruti. So you see the stress, the pitch variation actually is at different places, and also the timing, duration of some words, okay, some syllables. Rather, actually, in generation we deal with the syllables, each syllable of a word. If I say far away, and if I say far away, you see the pitch also varies and the duration also varies. So far away means actually quite distant, and far away means it may be distant. So due to the stress and the duration of far fa sound, okay, we know that it's the distance is much more than the other one. So, and there are liaisons between the words. Some words actually are related to other words as well. Okay, and finally we generate text as well. So how do we get from where do we get motivation for NLP? Why do we do so much of NLP task? The first one is we want to understand the language and analyze that and how it is generated. Okay, we want to study each language. We want to compare the languages. For example, we want to compare all the Tibeto-Burmese family of languages. So there are so many things. In India, some languages are from the Aryan side, from the Dravidian side, and there are quite specific classes in linguistics. I'm not actually into linguistics so much, so I don't have the correct terminology. But some words like Tibeto-Burmese family is there, like in northeastern languages. Manipuri may be different from the source of Manipuri may be different from that of the Mizo language. And in my side, my mother tongue is Nepali, so Nepali is a combination of Indo-Aryan and Tibeto-Burmese languages, because that is a culmination of a different ethnic groups. Communication is also one of the motivation things that motivate the study of languages. And of course, language is a window to the mind. We also think in some language. While we are thinking, we are either thinking in English or Hindi or Bangla or something. We generally think in our own mother tongue. So that is why we say language is a window to the mind, and that is one of the sources of motivation. And data is in linguistic form, and that is a great challenge, because it can be structured like XML or something, but mostly we have the unstructured sentence form, and we have to break down those, and that's a very, very challenging task. Okay, we have to deal with unstructured data a lot. And we can also view language as a phenomenon. Okay. Now, you see, language has always been influenced by actually factors related to history, traditions, etc. Okay, and it is directly actually related to the cultural and communication of a geographical region. Now, influence may differ from region to region. That's why we have the dialects. If we consider the Bangla language of Purulia, Bankura, and Bangla language of North Bengal, Bangla language of Dhaka, Bangla language of Malda, these are quite different. And we say, in the linguistic term, we say those are dialects. Okay, they are influenced by various factors like history, culture, traditions, etc. So it's an ever-changing phenomenon. And that's also one of the challenges. Language is not stable. Lots and lots of new words enter our language. Okay, and that makes and also the way we spell words also changes from time to time. Okay, and we can view language as data as well. So as both as phenomenon and data, and these are the sources of motivation, and now the basic things we will be dealing with in NLP. First of all, we will discuss about the levels. At what level do we process language? Level 1 is the speech sounds, and you see phonetics is a subject. It deals with the production and perception of speech sounds. Okay, and phonology is actually it is more complex. It deals with more complex an abstract sound. Sometimes that may not be there in speech. Okay, it deals with sound patterns and sound structures. Okay, so phonology is actually logy, the term, as you know, that it's a shastra, study of something in a more complex way. And phonetics is actually a part of linguistics. Linguistics, if we deal with the speech sounds, then we say it is phonetics. For example, we deal with this vocal cord, from where its sound is coming. When we are speaking in our natural language, the sound is not always coming from the same place. Some are palatal, some are levodental, some are bilabial. Bilabial means the two lips. For example, P. But when we say F, we touch the teeth, upper teeth with the lower lip, and that is labiodental. Lip and teeth are involved. Sometimes only the palate is involved. Sometimes the throat down below is involved. So that categorizes this different sound, and due to the source of sound, we can process those sounds separately, and that helps a lot in sound generation and text to speech conversion, speech to text conversion, and so on. And level 2 is a bit higher, and words. In phonetics, we generally deal with the syllables, the parts of the words. Okay, the sound of the syllables, but in level 2 we deal with the words as a whole and their forms. So that is dealt by morphological analysis, lexical analysis. So we call them morphology and lexicon. And level 3 is the structure of sentence. And as I've already explained about the syntactic analysis, the syntax of the structure, syntax of a sentence is actually this the structure of the sentence, and that can be analyzed through parsing. The similar thing, like in the case of compiler theory, some of you may have dealt with the compiler theory. There is a particular phase called parsing after the tokenization. And so that deals with the rules of the grammar, how the sentences are formed. And level 4 is the meaning of the sentences, semantics. Okay. And level 5 is the meaning in context for a purpose. Sometimes we use the same word, for example, CELL, cell. A cell may be a prison cell, it may be a biological cell, or it may be a battery. Okay. So just giving the word cell will not make any meaning to the system. The system will have to then analyze the whole sentence, the words appearing with the word cell, and then analyze and make out the meaning of the word cell, whether it is a battery or prison cell or biological cell or something else. So, and pragmatics deal with those stuff. And level 6 is the connected sentence is sentence processing in a larger body of text. It deals with the whole, say, article or a paragraph. After understanding each word, each sentence, and then we have to understand the whole paragraph. So after reading a whole paragraph, we may understand that it is a political writing, or it may be a religious script. Okay. So this is actually used a lot in sentiment analysis. For example, when we analyze say Facebook postings or Instagram postings or something like that. Now, what resources, data resources, do we need? First of all, to process natural language. It is not so simple. So we need the help of linguistics. We need to understand all the linguistic terms which deals with a particular problem. We have to understand the problems, problem domains in the linguistic area of a language, and also the phonetics. It is all, although it is a part of linguistics, but it is dealt with separately. Then there is a marriage between the computer science and linguistics, and what we say computational linguistics. Now it has become a separate area of study. Linguistics itself is science, very complex science, but then we add the essence of computer science into linguistics, and that form the computational linguistics area. And some of you may have already been into it. And script grammar is one of the most important resources, mainly for text processing. Now, script is very important to every language. Some of the languages have not been able to thrive, even die out, or at par with other languages due to the lack of script. They may have script, but that may have been forgotten due to less use, or not passed from generation to generations, etc. Now, why script is so important is, when we say script, we deal with alphabets of a particular language, first of all, so that with the help of those, with the combination of those alphabets, we write whatever we speak. Our alphabet system has been designed in such a way that will include all the sounds of our language. For example, in English, we have ABCD. Okay? And all the sounds of English language can be written using ABCD. But if I want to write some Hindi word in English, I may not be 100% correct. I may give you another example. For example, if I want to write fan or van in Indian language, I'll not succeed because the sound of F and V we don't have in our I don't know about other languages, but so far I know that Indian languages don't have labiodental sounds. Labiodental, I've already spoken before also. The lower lip and the upper teeth combination. F, fan, van, very. The V and F sounds equivalent are not there in, say, Hindi, Bangla, Nepali, etc. But we have BH sound, BH bha, and PH pha. We have phone. Okay, pha is bilabial. We touch our two, we close our lips together. Pha. It is not pha. Pha is for fan, and pha is for PH sound. Pha. So, because we don't have any such sounds in our language, we don't have that particular character or alphabet. So, the Bangla Ko Kho or a Hindi, that is Devanagari or a Ko Kho has been Devanagari is a superset, and there are subsets like Marathi. Marathi is also written using Devanagari. Hindi is also uses Devanagari. Nepali also uses Devanagari, but the Marathi alphabet and the Nepali alphabet varies. They are subsets of different kind because some Marathi sounds are not there in Nepali. So a particular script language has its own script which encompasses all its speech sounds, and with the help of those we write the text. So it's important to have a grammar, how we write the words. It is not the grammar of the words as a whole, but how we create the words. That is script grammar, how we write. Then comes CLDR. It is a depository or repository where we collect words particular to that language and is quite related to the culture and communication of that particular language, and that is local to that particular language. For example, I can give Bangla example like ek mutho chal, mutho. So it is a unit of measurement, but it varies from size to size. Ek mutho for a child and ek mutho for a big man like me, it varies in quantity. So we all compile all those words like mutho, like land measurement like chota, kotha, the days, Som, Mongol, Budh, the months in our language like Boishak, Chaitra, Boishak, Jeshta, and so on. So these are all collected and stored in a particular way in CLDR. You may go to unicode.org and go to the language of your interest, and you can find the CLDR and script grammar of that particular language. You can also find the Unicodes for the script, all the characters used in that language, and also the script grammar, the CLDR, etc. And these are very, very important in various. Now you have to note that all these resources are not needed in all applications, but they have specific tasks. But in, for example, I think in spell checker we need all those things. We need the script grammar, we need the CLDR, okay, we need the linguistic rules and all, and above all, the most important is the corpus. Corpus is a huge repository of the languages, probably containing all the words of that particular language. Now, it may vary from the plural is corpora. Yeah, the plural form is corpora. One corpus, two corpora. And it may be monolingual, means having only one language. It may be parallelly, and it may be multilingual. We collect all the sentences, words, and store that in a particular fashion. It may be text corpus, written corpus. It may be audio corpus. Okay. It may be related to a particular domain, like tourism, because you see, in each domain we have a vocabulary, okay, and those are not used in other domains. In medical science we have its own vocabulary. So when the medical representatives meet together, they talk to themselves, and if we say hear them, listen to them, say maybe accidentally, or we can overhear them, then we won't be able to understand some of the words, because they use their own jargon. What we say jargon, because those words are spoken only among themselves. So we may have corpus related to that. We may have corpus related to poetry. We may have corpus related to a particular area, like ancient times, medieval times, modern times, etc. And different corpora may have different purposes. And what we do is we collect huge, in a general corpus. If we talk about a general language corpus, what we do is we actually classify the sources, like newspapers, magazines, textbooks, novels, drama, history, geography, tourism, health, agriculture, and then even invitation cards, say maybe for marriage ceremonies or other things, visiting cards, the scriptures written on different monuments, stone scriptures, okay, whatever. We collect all those things, and we have to plan in advance that what percent will we take from newspaper, what percent will we take from magazines, what percent will be text from school textbooks, and so on. And collecting all those, we make a huge collection. My experience, I've been collecting a corpus of around 15 lakh words. Okay, and that does not mean that the language has 15 lakh words, but from different sources, we collect the sentences and type. And the one word may be here and there and everywhere. Okay, so there may be repetition. But if we make a huge corpus, there is a chance that we encompass all the words of that languages, barring very few. Okay, and we do for different purposes. We have to do annotation also. Annotation means we mark each word with the parts of speech. Okay, POS tagging, but I'll come to that. And then we do parsing, we can do chunking. Okay, those are different tasks. Okay, chunking means the noun subject part and the object part, subject and predicate, what we say, we keep separately those two words. So that may be used in some applications. Okay, and depending on applications, we need only POS tagged. POS means parts of speech tagged, means each word will have some marking which will indicate that it is either noun or verb, or even the type of the noun, like abstract noun or common noun or something else. The type of, if it is a verb, type of verb, if it is an adjective type, each word is marked with, tagged with that part of speech of that particular word. So corpus is very, very important. Example is we may build a spell checker prototype, and you see in Word, if you type a wrong word, then it will underline, and we can add that to the dictionary if it is correct. If we think that that word is correct and still it underlines that, then we may have, if we right click that, we may have some suggestions, as well as there are options to add to the dictionary as well. So parallel to corpus, we also need the dictionary, and we add the a particular word which is new to the language into the dictionary, and slowly the dictionary becomes richer and richer in vocabulary, and finally it becomes good at detecting spelling errors, but that may not be still 100% correct. Okay, foolproof. So what are the subtasks then? I've dealt with the resources. So first task is the tokenization. When the sentence is typed, we have to separate the sentence into words, smaller units. Sometimes in speech also, we can break the sound into some syllables, and each syllable may be treated as a token. So it is done by the lexical analyzer. Breaks up a string of words into semantically useful units called tokens. Okay. It may break the sentence into words, and that may have some semantic uses. And we do POSI, what I was just talking about in the previous slide. Tagging the parts of speech in each token. Okay. Sometimes this O is written in the lower case. This is very, very important. And that we cannot do that randomly. Okay. To deal with POS tagging, we need some standard tag set, and that standard will be defined by some group of experts in that particular language, and that has the name also for them. If it is done by say IIIT Hyderabad, then we say IIIT Hyderabad tag set, or it may be some group, say Bhasini tag set, and so on. So though people experts in that particular linguistics, in linguistics, they sit together and define the tax set of a particular language. And then we may use that tax set. And if we use a particular tax set, then we will have a standardized US tagged text or speech. Then we do dependency parsing. Okay. What does this mean? Is the way the words in a sentences are connected. Each word is actually connected to another word. One word depends on the other, which actually defines the structure of the sentence as a whole. So we do that. That's a kind of parsing. Okay. We also deal with inflections in dependency parsing. Inflection means there are grammatical categories like number, gender, tense, etc. And depending on this, the form of the word changes. In Hindi, we say आता है, आती है. Sometimes आता है, sometimes आती है. Because it is inflected by, influenced, affected by the tense, gender, masculine and feminine gender. So there are grammatical categories. Those are the senses of the sentence which affect noun, adjective, verb, etc. In my own language, there are a lot of such inflections. In Bangla, say, tense, khabo, খেয়েছে. Khabo means future sentence. খেয়েছে means past tense. So you see how the word is changing, the form of the word is changing. So there are other inflections as well. In English, for example, R-E-A-D, read, is written same as R-E-A-D, read. I will read the book and I read the book. Both the spellings are same. So here the parsing has to be done in the speech label. Because the two words are same, the inflection is not there in the text label, but in the sound label. In one we say read, in another we say read, although we write the same words. So there are various types of inflections, various factors that inflect the words, and it may be at the text level, it may be at the speech level, or it may be both. Also, how the language sentences are formed. Now, SOV, SBO, BSO, these are structures. Okay, there are others as well, like SO, you can say VOS, OVS, etc. But the percentage is very small. Now, what do you mean by this? Is SOV means subject, object, verb. Ami, apple, khabo. Subject is ami, object is apple, verb is khabo. Ami apple khabo. Okay? But ami apple খেয়েছি. I ate the apple. You see, in English, the verb comes in middle and the object is at the end. So in English is generally SVO. most of the Indian languages are SOV, subject, object, verb. And you see, these are the world figures. SOV comprises 45% of the world languages and SVO 42. These are the most general forms. And some languages, there are VSO structures like 9% and others are 3% nominal. Very few, maybe one or two languages in the whole world in other forms. But sometimes there are exceptions. Like in Bangla, it is SOV. আমি গান গেয়েছি, but sometimes we write গেয়েছি আমি গান, when we write poems. So those are exceptions. In poems, we change the structure of sentence to target the rhyming factors. Which word we will use at end, we want to rhyme with that in the next sentence. So these are exceptions, but in general text, we don't use such structures. I always say আমি গান গেয়েছি, but not আমি গেয়েছি গান. But yes, আমি গেয়েছি গান can be found in poems. So these are exceptions, and these exceptions actually create challenges. Another example is in poems. We also change the EM, because we have both short and long forms in spelling, Raswa and Dirgha. That is not found in other world languages. In Indian languages, we found Raswa E, Raswa U, Raswa Dirgha E and Dirgha U. And so sometimes we use Raswa E and Dirgha E. That's why spellings are very, very complicated. For example, din. Din is Raswa E. The Raswa E din is day in Hindi, and the Dirgha E na din is actually garib, very poor in Hindi. So sometimes we purposefully change Raswa to Dirgha and Dirgha to Raswa in poems to deal with the chanda. There is a particular term in poetry, that is chanda. So to incorporate that, to adjust that in chanda, we deliberately change the sentence, and that is not an error. That's why while building corpus for spell checkers, we don't include poems. We can include poetry, because poetry don't deal with poetry means those one is verse poem poetries, and another is prose poetry. And nowadays the poets don't write in mostly in Indian language. They don't deal with the thing now. So today's poems and poetries can be included in the corpus, but whatever we have read in when we were children in school, we generally don't resort to include that in corpus, because they have deliberate spelling, I don't say errors, but spelling differences, and that will hamper the quality of the corpus. Because sometimes we get corpus from some sources, and after checking we see there are a lot of errors and noises. So we have to resort to a step called corpus cleaning. Like it's a form of pre-processing the data resort. So we have to do a lot of corpus cleaning, and after that we have a gold quality corpus, clean corpus. Then only we can use that for our natural language processing tasks. So Another is constituency parsing. We have dealt with dependency parsing. The constituency parsing is in identifying the entire syntactic structure. I think I have only 18 minutes left, so I have to be a bit quick. And we also deal with the phrases, okay, how the phrases are formed in a particular language, and that deals with and that is dealt by the phrase structure grammar. Here the role of automated theory is very, very important, as people having the computer science background know very well that we use this in the in building parsers for compiler design. These two words are very important in pre-processing the NLP data. Reducing the words to root forms, what we call lemma, can be done by stemming and lemmatization. But these two terms are different in the sense that stemming does only cuts the later half of the word to form the root, but it does not always reach the particular root, because when the word form may change. I'll give some example here. You see, is, are, am, were, been, the root is actually be. So stemming can't do that. Stemming can cut the full in playful. So suppose the word is, the root is play, and we can form the word by adding other suffixes like playing, ing, played, playful, player. All these are related to the root player, and stemming only cuts those suffixes and brings to that to the root play. But it is not possible for stemming to change is, am, where to be. It is the root. So the meaning of the words rather than the form is very, very important in natural language processing. So we need lemmatization, and generally we use the lemmatization for pre-processing our NLP data. In Bangla, I can give you one example, very often used, like gechi, ami gechi. Will actually, the word gechi will be lemmatized as jabo, not even jabo, jabo. Because you see, the whole format, jaw has changed to go, and that makes the particular essence of that language. Khabo and khechi is also different, because in khabo we have kha a, and in khechi we have kha a. So how does that change? Makes stemming impossible, and so we resort to lemmatization. And there also we can go for various AI tools. Generally, we do machine learning, use machine learning techniques to train the system to deal with all these things. And we generally remove the stopwords like very often used, which are not very, we do not have so much of importance, significance in that particular language, like which, to, at, for, etc. We can just remove that while pre-processing if we are using for a particular application. In some applications, we may not do stopword removal because This may be quite significant to that. Okay. For example, in machine translation, we don't generally do this. And finally, we have the word sense disambiguation. What does this mean is, after lemmatization or space stemming, if we have a root word, but still that has to be understood, because if that has several meanings, then that will create ambiguity in the language. So we have to remove the ambiguity created by the sense of the word. I gave you an example previously of the word CELL, and that is dealt with by the word sense ambiguation. A very good example is the meaning of the root word book. So it may be read a book, it may be book a ticket, it may be close the books. Close the books means close the accounts. It may be do something by the book, means according to rules. In cricket, we say book is shot or something like that when a particular shot is played according to some defined way of hitting the ball. So, and also booked under section 34 and so on. So, book means you have been detained by the police. So you see, the same word book appears in with different meanings, different sense, and that has to, the ambiguity caused by the sense has to be removed. So we say word sense disambiguation. Okay. So they can be done by the knowledge based approach or training to learn from data. Okay. In earlier days, a lot of rule-based systems were used, but that had limitations, because there are so much exceptions in all languages, and exception handling is very, very tough. So nowadays it has been quite easy by using the machine learning approach, but for that we need huge resources. The data has grown to a large amount. I think yesterday one of my students, ex-students, Tirthankar Ghoshal, delivered a lecture for you, so far I know, and he dealt with large language models, and that's why actually this topic has been kept in, although it is about data science and its application. So this is one of the areas where the data grows very, very, very to a large extent, and then we resort to the techniques of data science to manage this data. Okay. And also the resources, missing resources. Okay. So I have 10 minutes left. So and finally we do named entity recognition, text classification in predefined categories. Okay, as I've already talked about this, like sentiment analysis, whether it is political writing or religious writing or something like that. By taking the chunks of words, we can classify them, and we need a good classifier for that. And here also, each step needs some technique, and mostly all the steps we deal with nowadays are done with the help of machine learning techniques. Okay. So in the Indian perspective, what is being done, where is being done? So why it is so much important, why NLP research is actually given so much importance in India is a multilingual country. Okay, so we have so many languages, not are all scheduled, but still used quite a lot, and we have a lot of percentage of literate people who only can write his or name, but only 6% of literate people know English. So Now, why English is important is that all the time new gadgets are coming out at a high pace. Okay, every day we find a new gadget, and to use that gadget we need to know English. But if we can use that in our own language, if we know our own language, even if we don't know how to write, if we can speak and listen to that, then we can use that language. For example, a farmer has a mobile phone, or a fisherman has a mobile phone, and he receives an SMS. Okay, like there is a cyclone coming, weather warning, but he can't read that. But as soon as he receives SMS, he can touch the SMS, and the mobile phone can read out the SMS to him. So he does not have to read the SMS. So after touching it, he can, or he can speak to the mobile phone to send some email or send some SMS and so on. So without knowing how to use the how to use without knowing the language, he can use the gadget with the help of this natural language processing products. Okay, and yes, there is used to compulsion to use the gadgets. If we don't have the mobile phone now, then we can't work. There are so many gadgets around us, digital gadgets, which we are bound to use, because if we say I will not use the mobile phone, then I will be outdated and I can't fit in the society now. And government of India from long time back has vowed to reach every corner, to every citizen, whether he knows English or not, whether he is literate or not. So the government of India has this. So due to that, and we talk about digital India, as the present government has already announced. We want to be smart and advanced, and we have the deadline of 2047. So, and most fortunate thing about us is that India has, so far I know, the data rate using the rate of using data is the cheapest among in the whole world. I think in India we are always connected. If you go to Nepal, then you only can use your mobile phone, internet in the Wi-Fi. Otherwise, if you use the data from your telephone provider, then you have to bear a huge cost. So, wherein in India things are happening in NL phase, private companies always are there. Microsoft, Google, other companies are there into it, the whole industry, and the MHRD and MITI, Ministry of Electronics and Information Technology. They are the two big players in this area, and other ministries as well are there. And a lot of researches are going on in IIITs, NITs, IITs, okay, and different universities. Yes, the CDAC is there. CDAC Pune, CDAC Kolkata, CDAC Noida is also there, I think, CDAC Noida. And the CIIL is actually the head is office is located in Mysore, the Central Institute of Indian Languages. And they have branches somewhere else in India also. I know about one branch in Guwahati. They do a lot of research. And you people also can contact CIL people to do NLP task and others. And of course, different universities are attached to different tasks, mostly in consortium mode, where different universities, IITs are forming groups, and they are dealing with the same task in different languages. So that is mostly in consortium mode. They are forming. This is one of the bodies, okay, of the Ministry of Electronics and Information Technology. You can hook to this and you can view a lot of resources which are free to use, and also you can know about whatever is going in India about Indian languages through TTIL, okay. Technology development for Indian languages. This is under the Ministry of Information Technology. You can also hook to the Unicode Consortium, as I've already told you, unicode.org, and know a lot of things about these basic tasks. So activities going on, and designing typing tools and fonts, they are almost outdated now, and machine translation. A lot of tasks is going on in this area. Text to speech, speech to text, print text and handwriting recognition, spell checker, lexical resources like WordNet. WordNet is there. Maybe like thesaurus, but it is not thesaurus. A lot of resources are there. You can hook to that. And then we do sentiment analysis and everything. Other activities like email filters, like spam filters and all. A lot of and nowadays, even in cyber security front, we can use NLP to filter the emails, so that we can block the phishing things and all. Then we have the virtual assistants, voice assistants like Siri, Google. Okay. Then we have search engines, predictive text and autocorrect. Okay, while we are typing some messages, you get predictive text. What will come after that, and you don't have to type the whole word if it is there in the predictions. We use the autocorrect features. Then we have business predictions, chatbots, which are very, very popular nowadays, and you are all aware of those, and a lot more are there. So I think I will not want giving you the list, so you can search yourself. Challenges are because human languages are ambiguous, as you already know. Lot of ambiguity are there. Sometimes even humans if you question yourself, do you know your own language, your mother tongue 100% correctly? May not. That's why we need explanation sometimes. So one challenge is that in Indian languages, though some of the languages like Bangla, Tamil, Hindi, they have a lot of written resources, but other languages like Nepali, Bodo, okay, Manipuri, they have Maithili, they have very little resources. So that's a great challenge, and they have to build their own resources, then use those resources for research. And we have the sarcasm and humor, okay. I can say I'm feeling hungry in a very different way. I can use other sentence, but I mean that I am hungry, okay. So, and we need powerful algorithms and machines. We need servers having GPUs, lot of processing power. That is a great challenge. So what we generally do is, if we don't have these facilities, if we can't hook to any GPUs, because you see, for running all the huge training the machines with huge data size, okay, training data, and we need epochs and epochs of running the machine learning algorithms to build our model, to train our model, we need huge data. So what we generally do is, if we don't have the hardware, then we can use Google Colab and others. There are other systems, so we can buy that on monthly basis or hourly basis or even yearly basis. They have their things, and we can let them run for the whole night and so that we can get our required things in the next day and so on. Yes, data size is growing and growing and growing, and we are now we have these large language models, as it has been discussed yesterday. So the size also has to be managed properly, huge amount of data. And there are contradictions among linguists. Some say, let's write the spelling this way, other groups say no. So we want to follow, because we have to listen to the linguists to deliver the NLP products. So if we listen to one group of people, then other group of people will say your system is not correct. So there are debates among linguists, and that creates a lot of challenge. Generally, there are debates regarding spelling and grammar. So I don't want to give this in detail. It has been already spoken during my introduction. So these are my involvements so far. So I think I'm done with. I've crossed the limit as well. I'm so sorry. I didn't notice the time. It is already 12. So
thank you, sir. The session was incredibly insightful. Sir, you have correctly said that the country like India, we need most research in NLP. So I have a question, sir.
yes, please go
Sir,
ahead.
what are the prerequisite knowledge required to do research in this field?
Actually, what's your background? That is important. If you are into computer science, then yes, AI and machine learning knowledge should be there. And actually, it is rather better to collaborate with some linguistics experts, linguists, and do the research together.
Yes.
And they will give you the data resources, and you will give the technology. And actually, most of the research are done in interdisciplinary fields like this only, by forming a team of experts in their own domain and then sharing your knowledge together and doing the research. If you want to go alone, then you have to actually learn a lot of linguistic theory.
Okay, thank you, sir. Thank you for your outstanding presentation. So, sir, we look forward to the opportunity to collaborate with you again in the future. Thank you, sir.
Okay, thank you so much. And so I want to express my deep sense of gratitude to, of course, the organizers for giving me this opportunity, and especially Deepanjan Sen, one of my old students.
Thank you, sir.
And
He's still your student, sir.
yeah. My project
thank you, sir.
consultants and staff members from who I've drawn a lot of resources for preparing this, and of course the audience and all those who helped me in preparing this presentation.
Okay, thank you, sir.
Thank you, sir.
Thank you so much. And I will need the feedback from Deepanjan whether
Yes,
I
sir.
was capable of satisfying your needs or not.
No. Yes, yes.
Okay. Thank you so much.
Okay.
So I'm signing off.
Yes, sir. Thank you, sir.
Thank you, sir.